Example 6.11 is going to walk us through finding derivatives of logarithms which have a base different than Euler's number e. For instance, this log base 5 over here. And just like the previous video, I am horrible at memorizing, so I have to derive this rule every time. If you already have this memorized, go ahead and skip back to when I come back to this box. But I need to play around with this. I need a way to differentiate any logarithm, right? Base A, where A is anything. Well, I don't know what this is equal to, so I think this is a really cool proof. I'm just going to call it y. I'm going to literally just give it a name. I don't know what it is. In fact, I'm trying to figure it out. And by rewriting this as an exponential, we have a to the y is equal to x. And I want something in terms of natural logarithms, right? Because I know something about the natural logarithm. That differentiates to 1 over x. Right? The derivative of that is equal to 1 over x. So if I apply a natural logarithm to both sides, I can use my rule of exponents that says I can take that y and move it down in front. And almost magically, there's an equation for my y. My y is the natural log of x divided by the natural log of a, which is that thing that I just guessed at. Cool. So I can rewrite any logarithm as a natural log divided by the natural log of the original base. So using this fact, if I want to differentiate any logarithm, that's me differentiating the natural log of x, which is 1 over x. But then by the chain rule, I multiply by 1 over natural log of a, right? The derivative of, well, actually, it's just not even the chain rule. It's just a constant. All right. So that gives us this rule right here. Now let's put it into practice. Y prime, if y is equal to 3 times the log base 5 of x, the 3 is a constant. It doesn't affect the derivative. The log base 5 of x will become a 1 over x natural log of 5. Here, y prime will equal 1 over x. In fact, let's just keep with the rule, natural log of e, right? Because if I rewrote this natural logarithm as a log base e, then it differentiates to 1 over x natural log of e. And natural log of e is just equal to 1. So that's why natural log of x just differentiates to 1 over x. And this term will differentiate to 1 over a 2x natural log 2, but then multiplied by 2 because that's the derivative of the inside. So cleaning this up, we get 1 over x minus a 1 over x natural log 2.